Hi guys, so this part of the video is going to be called Matter and Change. By the end of this specific video, you should be able to understand the different branches of matter and how to identify elements and compounds both through diagrams and through annotation. So as you recall, we have defined matter as anything containing mass and volume. What you have not been taught yet is that matter can be broken down into two branches. There are pure substances and then there are mixtures. Pure substances are pieces of matter that cannot be separated by physical means, while mixtures are defined as pieces of matter that can be separated by physical means. Now I understand we haven't discussed what physical means are and chemical means, but we will learn that in our next video. Now, pure substances are then classified into two branches itself. We have elements and we also have compounds. Now, elements are the purest of pure substances, as they are made up of only one kind of atom. Now, because they are made up of only one kind of atom, they cannot be separated by chemical means. They are the only type of matter that cannot be broken down any further. So again, they are the purest of pure. If we break down an atom any further, then we lose the material that we consider matter. So that is why we say that elements cannot be broken down further. Compounds, on the other hand, can be broken down by chemical means because they are chemically combined of two or more elements. Now they are chemically combined compounds, therefore we can chemically break them down. Mixtures, unlike substances, can be separated by physical means because they are physically combined of two or more substances. So remember what we said a substance was. They're elements and compounds. So mixtures are a physical combination, or for lack of a better word, a physical mixture of either elements and other elements, elements and compounds, or even compounds with other compounds. Now, mixtures can be broken down into two groups themselves: homogeneous mixtures and heterogeneous mixtures. Now, the prefix homo stands for the same. So what we're saying that is the same in a homogeneous mixture is actually its appearance. So it looks the same throughout. We call it uniform. Heterogeneous, on the other hand, refers to something that is different. So again, we're talking about its appearance. The appearance looks different, so it's not uniform. An example of homogeneous would be air, because it's made up of many different types of elements and compounds, but we don't see the difference. You can't just look in the air and go, ooh, there's oxygen, and grab it and absorb it into your lungs. Now, heterogeneous mixtures, we can see the difference. So think of like a salad, right? You could see the lettuce, you could see the tomatoes. Now let's look at matter on a molecular or a particle level. Elements, as we said, will only contain one kind of atom. As you can see in both of these examples, they're going to represent elements. They represent elements in different ways, but again, they go with the idea that there's only one kind of atom in there. When we look at the example on the left, we see that atom A is the only kind of atom in this box. It doesn't matter that atom A is clumped together with other atoms of A. We just want to make sure that it's the same kind of element that is touching together and that makes up the entire box. So that is why it's considered an element. Now the example on the right makes a little bit more sense for most students because it is one atom and it's only one by itself. Again, these are both considered element examples or element diagrams because there's only one kind of atom inside both of these examples, and they make up the entire sample. Now, when we look at compounds, compounds look a little different because they're going to contain two or more elements chemically combined. So they're going to look like they're touching each other or fused together. So if you look at the example on the left, we see that there's two different kinds of atoms chemically combined or fused or touching together in that picture. Now the reason why this is considered a substance because substances are pure throughout the whole sample. Notice that there's only one thing in this box. They all look the same. Even though it's containing two different elements, they're touching in all the same manner. So there's one atom A touching or joined with two atoms of B. In the example on the right, it's the same kind of idea. There's only two atoms that are touching or joining, so they are chemically combined as well. The whole sample looks exactly the same, one atom of C, one atom of D, so that is also why it's considered a compound particle diagram. The last example are mixtures. Now, mixtures cannot be considered homogeneous or heterogeneous in a particle diagram because in a particle diagram, it's too small to identify whether the pieces will be visible to the eye or whether they'll be invisible. The first example has two different substances, but they're just two different kinds of elements. So you'll see that atom A is by itself in the box, and you'll also see that atom B is by itself and in the box. Again, it doesn't matter that B is clumped together with another atom of B as long as elements contain one kind of atom. In the second example, we have compounds only. Again, you're going to see two different kinds of substances, which means that there's two different compounds in the box together. Now, the last particle diagram is going to be elements and compounds. Again, two different substances that make up a mixture. In this case, the whole picture diagram represents one element, so one single atom, kind of all in the box by itself, and then one compound all in the box by itself. When we read about or write about different kinds of matter, we will see that chemical symbols and formulas are used. Now, a chemical symbol is going to be used to represent elements, and we can find those chemical symbols on the periodic table. So if you open your reference table to page 9, you will see all the elements that have been discovered and their symbols in the little boxes that represent the elements. You will also notice on page 9 of the reference tables that chemical symbols are going to contain one or two letters, and they're going to represent Latin or English names for the element. So for example, gold has a symbol of AU. It doesn't match with the English name of gold, but it does match the Latin name for gold, which is aurum. Now, a chemical formula is used for compounds because formulas will include two or more different symbols, which should make sense because compounds are composed of two or more elements. Now, when we read or when we write down a chemical name from a chemical formula, so a chemical formula is only the symbols. The chemical name is writing out the elements itself that make up the formula. But when we are writing out a chemical name, we're going to include all the different types of elements that make that compound up. So everything that we see in the formula will be in the name as well. So this ends the first video of Matter and Change. Please try to review the video at least one or two more times so that you are certain that you have covered everything and that you come to class prepared. Have a good night.